Well, as we gradually adapt to the new normal, AABN continues its engaging webinar series to keep you connected with the eminent minds and emerging trends in the comfort of your homes. Today, we have one such personality, Mr. Rajamanickam Ramanathan, a respected professional and an educationalist. What makes him an apt choice for this audience is that he too is an alumnus of Annamalai University and he belongs to the 1987 batch of Civil and Structural Engineering. While preparing for today's event, my thoughts raced down memory lane. Though we never got to interact freely with many of our batchmates, they are still undoubtedly an important part of my cherished Annamalai memories. It came as no surprise when I chanced upon studious Ramanathan many years later and I've been able to follow his stupendous success. Whether it was his work in Singapore or in pushing the idea of automation in the workplace, he has left his indelible imprint in all that he undertook. Today, he has emerged as one of the most sought after voices when it comes to issues relating to multidisciplinary engineering activities in the oil and gas industry. In today's session, the hydrogen blueprint from fuel and storage to production and policy, he will not only showcase his expertise in the field, but also look at ways to improve business by focusing on various aspects. Before I hand over the floor to him, let me quickly run you through his achievements, a long list that has been cut short rather reluctantly by me to save time. Ramanathan is a structural engineer with immense experience in oil and gas installations, both onshore and offshore. He has a bachelor's degree in civil and structural engineering with a university first rank in 1987 from the Annamalai University, India, a master's degree ME in structural engineering by coursework from the same campus in 1989, and later another postgraduate research degree, ME engineering on random vibrations, tall structures due to wind, equivalent spectra method from the Department of Civil Engineering at the National University of Singapore, 1992. After studies, he has a total of 29 years of experience in oil and gas engineering. He started his career with Sembawag Projects Engineering in Singapore and moved on to Aker Kavilar as lead structural engineer and had carried out detailed design for several offshore jacketed platforms, including the foundations. After gaining experience, he moved on to Saipem Asia, where his responsibility included fabrication and installation of offshore jackets, piles, topsides, subsea pipelines as the lead installation engineer. He was with Saipem for 4.5 years for the onshore transportation and installation EPC works. He moved to Shell, where he has reviewed and approved many offshore platform detail engineering designs and T&I works during his tenure with Shell Malaysia at Min for its Sarawak field developments. He has designed and assisted the novel installation method for many conductor piles while at Shell. Later, during his tenure at Kebambangan Petroleum, KPOC Malaysia, a joint venture operator company of Shell Malaysia, ConocoPhillips and Petronas in Malaysia, he has successfully been involved in the installation of Malaysia's first heaviest platform, KBB, including its 14,500 metric ton jacket, skirt, and conductor piles, and float cover installation of 22,000 metric ton topsides. He was with KPOC leading the client review for EPC works. Presently, he is heading multidisciplinary engineering activities for various projects in the oil and gas business division of Afcons Infrastructure Limited, Mumbai, a Shapurji Palonji Group company in India. He is managing the entire oil and gas engineering and quality department work. He is also the chief editor of technical magazine, namely Samvada, issued by Afcons Oil and Gas Business Unit. He has contributed few papers on hydrogen energy in the magazine. On the personal side, the university circles remember Ramanathan for his warmth and his genuine value for friendship. With a personality like Ramanathan, you can go on and on eulogizing, but let me stop here and let the audience have the privilege of listening to you, Ramanathan. Over to you. Thanks, and over to you, Ramanathan.
Yeah. Thank you, Mr. Gopi. It is very heartening to see this AABN network is conducting for so many years, more than hundreds of such conference series you have already conducted and made knowledge sharing to many participants. And it's really a good social work. And thank you very much. And so with that, I thank all the participants for finding time during this Sunday to attend this session. So I think with this, let me share my PPT and then we will start to present the. If I'm not audible or if my screen is not visible, you can inform now.
Can you
So,
get it to presentation mode, Ramanathan?
Yeah, I will go to. Yeah, hopefully it's visible now.
Yes,
Yeah.
visible.
Yeah.
Yeah.
Okay. And am I audible also?
Yes, you're audible.
Okay. Yeah. Welcome to this presentation on an introduction to the hydrogen only, this one. Just to go behind my background, I am a civil structural engineer and mostly during my studies, I had ambition to become a chemical engineer, but I ended up into a civil structural discipline area. So always I had a good flair towards chemistry. So personally being interested, I just had my studies personally and then come out with some many information. So that is the reason. Recently, I had been into many seminars also in hydrogen and found that it is very highly useful to the society. But unfortunately, in India, this goal is not much pursued until late 2020. So this presentation is only an introduction from a guy who is not a chemical engineer, and hopefully you will agree with me if there are any further details if you would like to present. I already know there are many experts in this forum who have joined just now, like Mr. Stalin, Mr. Murali, so Mr. Murthy. So all these process engineers can also contribute and share if they have any further ideas than mine and better to this. So this is just an introduction section which you know already. Many of them know about hydrogen and its qualities, but it is just a refreshment session. So the topics I intend to cover today are listed here. So we start from what is hydrogen, basically its atomic structure. Then we will talk about why we need to go to hydrogen fuel or energy. So that why is very important now. Then we will talk about the properties of production of hydrogen. Then methods, the properties and types of production, and as well as the methods of production of hydrogen. Carbon capture methods, because we need to remove the carbon dioxide produced during certain methods of hydrogen production. So that's why I included this topic. And hydrogen storage methods and usage systems, basically applications. How do we use hydrogen produced? And we will touch up little bit on economics, then on the India's hydrogen policy, then hydrogen, good morning. Hydrogen supply chain and Indian players in hydrogen, as well as any other topics. At the end, I also have a small video about our Afghans, the company I'm working with. So some of their works we are involved, not only in oil and gas, in infrastructure. So a video will be presented at the end also, before the question and answer. So this is the brief agenda for today I have. So let us proceed further. So what is hydrogen? Basically, it's a element, is the very first element having atomic number 1 and atomic mass 1.008. It doesn't exist as a single atom, it's a diatomic in nature. So we always used to call hydrogen in the symbolized form H2, and it has a boiling point minus 252.9 degree, and it's a cryogenic temperature basically. It's actually minus. And the atomic structure of hydrogen has one proton and it has no neutrons. The nucleus has no neutrons, only one proton, and one electron is there on the orbit. So this is the atomic structure. It's the very lightest element you can see. So if you look at it, so these are what we have seen. It is a colorless, odorless, tasteless, non-toxic, and highly combustible gas. So being colorless, it is very little bit dangerous. It's not seen to naked eye. It will escape during in the leakage paths, but we won't be noticing. And sometime with the blue flame, even the flame is sometimes not visible. It is odorless, totally tasteless, and non-toxic. But it is a highly combustible gas. So that is the risk associated with the hydrogen. Basically, sun is a giant ball of hydrogen, and H2 is the lightest element on Earth. About 11 liters of hydrogen gas weighs only 1 kilogram, sorry, and needs 11 meter cube of volume. We have 1 kg of hydrogen. For 11 meter cube, 1 kg of hydrogen gas is the density basically, and has high energy content, 120 megajoules per kg per unit. The energy content is high by weight, but by volume it is low because it is less dense. And per kilogram of hydrogen gives 30.3 kilowatt hour. That is unit of electrical power. So 33 or 34 units of power can be derived from 1 kg of hydrogen. So now we come to the topic after the getting the properties. Why hydrogen fuel? So everybody is talking about hydrogen now. They are all talking about renewable energies, and hydrogen occupies very important position in the renewable source now. So hydrogen, there is no direct carbon dioxide emission because the element hydrogen doesn't contain carbon. So or no other greenhouse gases also it emits. Greenhouse gases are mainly except some traces of nitrous oxide, NOx it may emit, and it is also due to heating of air, not inherent. And this no carbon dioxide is burnt, and only hydrogen, it is a clean fuel. So that is why the reason for us to go to hydrogen is it doesn't emit any gases which are harmful to the environment, including greenhouse gases. Greenhouse gases are those gases which are like, nitrous oxide, NOx, carbon dioxide, water vapor, and even so those gases absorb the heat radiation from Earth and they remain in the atmosphere. And these elements increase the atmospheric temperature. So the Earth's atmosphere is getting warmer day by day due to these greenhouse gases which are emitted by our usage. Industrial use, vehicular transports, shipping transport, train, everything will emit from fossil fuels. So it is plentifully available on Earth, mainly in the form of water, and in fossil fuels also it is abundant. So it is because of plenty availability, we prefer hydrogen fuel. And high energy density also it has. When it ignites with oxygen, it forms water and releases heat. And the energy density is high with respect to mass, but not with respect to volume. And hydrogen can be produced and stored, but it can be used anywhere, and no extended use is expected. So you can use any time, you can store any long you want. Not like electrical energies, when a windmill is running, you have to tie to the grid to usage, and or you have to store it in batteries. So the efficiency also reduces. In hydrogen, it is not the case. Storage can be done. It can be stored for long periods without any significant losses. And it is an industrial fuel, which many industrial processes use fossil fuels, and they develop carbon dioxide, emit greenhouse gases. So to replace them, hydrogen is the clean fuel which can be used. So now the fossil fuel reserves in the world is depleting day by day. Saudi Arabia is having one of the largest reserve. Even they are getting depleted. Many reservoirs in Malaysia has already been closed, and of course many reservoirs are being discovered also. So it is because of the diminishing storage of fossil fuels on earth, we still need to find a way to run our business on earth. So we need another alternate energy. So hydrogen seems to be a promising energy of future. And these coal as well as natural gas, all these supplies are all fossil fuels, and they are getting depleted. Now, the reason for me to say why we go for hydrogen, we have seen some certain factors why we need to go into hydrogen energy. Now, there is another big reason why we are going in. If you consider the fossil fuels consumption, it goes up to 81% of the world's energy demand worldwide. This is 2022 data from IEA. So other renewable sources, like renewable sources only meets 11%. The fossil fuels also not clean fuel, and they induce global warming, glaciers melt, so many issues come. The hydro dam power, that is the hydrogen, the hydropower from dams, they provide 2% of the energy demand only. It is the most cleanest energy. And other renewable sources are also there. So in renewables, we have solar, wind, as well as hydropower. We have nuclear power also, which has 6% of the global demand meets. But nuclear energy is clean from carbon dioxide or most of the GHGs. But it produces a lot of radioactive waste that are toxic to humans and are harmful to them for more than thousands of years. Basically, in the world, no country has made a innovation yet to break this silence on how to manage the radioactive waste. They have been dumping it into by drilling into the earth too long and then dumping and sealing it. But nobody knows what really we can do. Research is still on the nuclear energy path. And why we may not able to go for solar also sometime is because we need a land area bigger. like 2.3 to 2.5 acres required to generate 1 megawatt of solar power. But these challenges in solar power are still there. Research is ongoing to improve the efficiency of the solar power extraction. So now another reason for us why we are going for the hydrogen power is there is a Paris Agreement behind this. The global warming happened. The climatic change conference happened in Paris in 2015, and in that at the end of the conference, they have drafted a legally binding international treaty that applies to all the nations of the world, almost 196 nations it applies. And what they say here is they pledge that all the nations have to reduce carbon and greenhouse gas emissions so that we hold the increase in global average temperature to well below 2 degrees above the pre-industrial levels. Pre-industrial levels are defined from 1850 to 1900 AD. It is the period where industrialization has not started. And what they say is now the global nations have to keep the global average temperatures well below 2 degrees of the pre-industrial level. And they have to pursue the efforts to limit the temperature also further so that we lie below 1.5 also. This is an ambition, 1.5, but the requirement is 2 degrees for any of the nation. So with this stringent condition, it is difficult to continue with the fossil fuel emissions every day. And at the same COP21, all the global banks of the world, including World Bank, Asian Development Bank, and other development banks, and including 450 public banks, they declared that more financial investment will be given to renewable energy sources such as solar, wind, hydrogen, but they reduced it for the fossil energy production worldwide. So that is the reason why the fossil energy production, exploration and production is coming down. That also is one of the reasons, except some big nations who have the resource and reserves. So these all strengthen the requirement of why we go for hydrogen energy. Hopefully you have understood. Now I'm going to the properties of hydrogen based on the color coding here. Now we define a hydrogen element as green hydrogen when it is produced. Actually, hydrogen is colorless. Don't confuse with these colors what we are saying. Hydrogen gas is colorless, odorless, as I said earlier. But these colors are the color codes we assign artificially to say this hydrogen is produced from clean sources like renewable energy. Like if you use the renewable energy like solar power, wind power, or hydrogen, then you or biomass, then you generate hydrogen out of it, then it is called the green hydrogen. Similarly, black hydrogen, you use fully coal or fossil fuel like petrol. So when you use them and then produce hydrogen, it is fully black. Gray is steam forming. Natural gas is used to do the steam reforming method. Then we get gray hydrogen where the carbon capture is not there. When you remove the carbon dioxide generated from this steam reforming method with the natural gas using carbon capture methods, then that kind of hydrogen production is called a blue hydrogen. In most of the Gulf countries, which owns a lot of fuel reserves in the earth, like Saudi Aramco, all these things, they're all going for and they're very much behind accelerating the blue hydrogen technology. So these are the basic color coding that people are talking about: green hydrogen, black hydrogen, blue hydrogen. So you should know all these details. Similarly, we have this natural gas, which is called liquefied natural gas, which is LNG. We also have that LPG at our homes. So that is different, liquefied petroleum gas. Then we have RNG, which is renewable natural gas, which is produced from biomass. That is RNG. So these are a few terms. CNG is also there, compressed natural gas. Just natural gas is getting compressed to a certain extent where it is being sold. Now, in blue hydrogen, when we use methane is the main, CH4 is the formula, is that compound which is used in the steam reforming method. And here the carbon dioxide is emitted after a second reaction, that is after a shift reaction. And that carbon dioxide is captured through carbon storage procedures. As you can see, there are different methods of carbon capture. CCUS is called carbon capture, utilization, and or storage. So CCUS is a procedure by which you can produce blue hydrogen. Without CCUS, the hydrogen is called a gray hydrogen. And blue hydrogen also, we can use it to produce blue ammonia. Ammonia is made of three hydrogen atoms, NH3, no? So it requires a lot of hydrogen. And these are the blue hydrogen technology under development in the Gulf. So the different methods of producing hydrogen are written here. Hydrogen production mainly is done in the world most popularly by means of steam reforming method. Highest amount of hydrogen produced by steam reforming method. And then you have coal gasification also. Then electrolysis. Electrolysis now gaining more momentum. And so the green hydrogen comes from electrolysis because it doesn't emit any carbon dioxide, anything. So it is pure. And we also have another kind of this green case. The biomass waste is being utilized, burnt, and natural gas produced from it is called renewable natural gas, RNG. RNG is again converted using steam reform method into hydrogen. And for conversion of biomass, we may use anaerobic digestion, where the bacteria doesn't see oxygen at all in a covered environment, and they break down the compounds, organic compounds of biomass into natural gas. So the main method of hydrogen production for green hydrogen is electrolytic method. Just the simple electrolysis process we have studied in chemistry. So there are two elements called anode and cathode. Anode is positively charged terminal, and cathode is the negative terminal. And there is a membrane which is separating them. This membrane can be an ion conducting media, and the electrolyte also is an ion conducting electrolyte. The electrolyte is the solution you can see there. Mostly the solution is salt water or some other acid. So this, what they do mostly is salt, NaOH, 30% solution also being used. So this electrolyte conducts the ions and into it through the membrane. And when we pass the electricity from say from a renewable source like wind power or solar power, then it is called green hydrogen. So that's what we have seen earlier. So a green hydrogen production is from renewable source like wind power or solar power. So you need a power supply here in this electrolysis process. That power supply should come from solar or wind, then it is called green hydrogen. So with that green hydrogen, then you generate green hydrogen using the electrolytic cell like this. Now the first reaction here is the anode reaction, where water molecule is split into oxygen and hydrogen, with the electrons, always go to the positive side, anodes, and O2 being negative, it will be absorbed through the anode entry, and the hydrogen particles being positively charged, they reach the cathodic side and they escape through the cathodic side, and hydrogen is collected from the cathode area. So that is the second reaction, which is the cathodic reaction. This is one of the electrolytic cell produced in India. Just the details of their specifications are given here. They are using 30% sodium hydroxide as electrolyte, and the stack size, they are going 3.8 to 4.4 kilowatt. This electrolytic cell produced by Bryce Chemicals in Pune. So some of the parameters are given here. The purity of hydrogen produced is almost close to 100%. And this is the next method, which I was saying is the coal gasification method. Here, the coal is fed into a rod mill, which combines with the water. It grinds it off, and in a slurry form, it pumps it into a gasifier. In the gasifier, we supply oxygen through a nozzle. And with oxygen, you need three elements to form fire there. So you need oxygen, you need fuel, you need a high temperature. So with that, you generate the fire, and combustion takes place in this gasifier chamber. Once the coal is combusted, it is quenched in water here. That this process, first process is called gasification, where we supply air and carbon feedstock with water as slurry here. Then after gasification in the chamber, the next step is it moves to quenching and cooling in water. This goes into water. So this reaction is nothing but the methane produced, basically some methane from coal. We are combusting and quenching in water here and cleaning it. Then it goes into a shift reaction, wherein the by second reaction called carbon monoxide with hydrogen, that is the steam we introduce. Then carbon monoxide reacts with steam to form carbon dioxide and hydrogen. So the hydrogen is separated out and carbon dioxide is separated out later. And that is in the fourth process. It is purified using, it is not shown here, but it is purified using a pressure swing absorption. It's called PSA in chemical terms. So with the pressure swing absorption, basically a solid carbon powder, like, activated carbon, they will pass the gas, and it will remove the carbon dioxide from it. And that is separately separated out and removed as part of CCUS. Unless the CCUS is done, the hydrogen produced from this process is termed as is not termed as blue hydrogen. It will be either gray or black or brown. So that is the reason why we need to do carbon capture and storage safely. So the hydrogen is then classified as blue hydrogen. Basically, we are trying to prevent environment from carbon getting diffused into it, because carbon is harmful to the environment. So the second method is the steam methane reforming method. Here, the methane is a gas, in the natural gas. Mainly, it comprises of methane, and it is passed into a cylinder with wherein steam is also injected. With the steam and methane together, and the reaction is endothermic. That means it will absorb some heat for the reaction to proceed. So reactant has to become a product through an assistance of heat. So this reaction is called endothermic, and here we supply some heat through means of steam and things, and it produces finally again carbon monoxide and hydrogen, as we did last time in coal gasification. Then the second part of the reaction is called the water gas shift reaction, wherein the products of carbon monoxide and hydrogen again they are not treated. Carbon monoxide is treated with steam, hot steam, and it separates carbon dioxide and hydrogen again separately, and also emits small amount of heat. So this reaction is exothermic because it emits heat. So this is the process of steam reforming method. And here it is not mentioned, you have to remove the carbon dioxide produced and store it safely or utilize it. That is simply implement CCUS frameworks. CCUS framework is a big framework under research now. So next is the carbon capture, what we have been talking about, CCUS. In order to reduce the environmental damages to the atmosphere, carbon dioxide gas produced during the blue or brown hydrogen production has to be captured. And how do we capture? So there are two methods. You can either utilize it, the carbon dioxide, or you can capture it in drums and later into reservoirs. So we will see about such a detailed method shortly. There is a method of utilizing carbon also, that carbon dioxide. Many companies started researching on how to utilize the carbon dioxide produced. Basically, they are trying to form carbon-based products, building materials, chemicals, etc. Companies like many research institutes and companies like Saudi Aramco, they are in a big way to utilize the carbon instantly than storage needs. So they can also be stored safely in underground reservoirs so that it doesn't come in contact with the atmosphere. So that we will see later. Storage in underground reservoir is found geologically existing. So there are already carbon dioxide naturally occurring under the reservoirs below Earth. So the rock traps the carbon dioxide in the geological condition below Earth, and they are already existing. Naturally occurring carbon dioxide is already existing. So this phenomena gives rise to researchers that the extra produced carbon dioxide from all these processes can be injected into a geological formation, a reservoir, and seal it so that it can be safe for the environment, as well as it satisfies nature, because naturally occurring carbon dioxide already is found trapped below the reservoirs for over 1 million years. For example, Bravo Dome field in US, there the natural geological processes have trapped carbon dioxide for over 1 million years already. So it is not new that we are trying to inject carbon dioxide into ground. It is already a natural process which is there, which is existing. So whatever we produce carbon dioxide from all these processes of hydrogen making, So we can think of injecting such carbon into such reservoirs in a big volumes. Because if you store it carbon in containers, how many containers you need and what is the energy required to produce containers, and so much of cost is there. Whereas you just simply drive it into earth and trap it into the reservoir, seal it, and you must have a framework to monitor and control them. The reservoir control management should be there. This we have to also see, we are identifying such underground reservoirs or resources to capture carbon so that they are not near any water aquifers where people are getting drinking water, and it doesn't contaminate drinking water or any other sources or any other minerals. So the selection of reservoir has to be identified correctly. In fact, US agencies have so many environmental regulations. EPA has been established, guidance framework has been established for identifying such kind of reservoirs. So some of them, saline formation also in near aquifers, they store the carbon dioxide. Now the recent trend is to store the carbon dioxide into the depleted oil and gas fields, the reservoirs below ground. And in fact, it serves two purposes. One is it can really store the carbon dioxide into the reservoirs, as well as it can basically it also pushes the oil and gas reserves, which is already existing in these reservoirs. And such oil and gas reserves under pressure with extra injected carbon dioxide. So under pressure, an enhanced recovery, which is called ERO, if it is enhanced recovery of oil, which is also called ERG, if it is enhanced recovery of gas, can be done by basically by depleting the oil and gas reserves. And we also have some unconventional rocks like igneous and basalt coal seams. So those are the things also where we can store them below ground. And some of the basalt storages is not good for carbon dioxide because basalt reacts with carbon dioxide. So this is the pictorial view of what we have been talking about now on the carbon capture. So the carbon produced is injected by drilling the ground into so many kilometers inside to reach the geological reservoir formations, and it is injected there. Either it can be injected from onshore wells or from offshore wells. So you can see from here. Mr. Dhanasekaran, I think some sketches are going. Yeah. So in the carbon capture framework, we have this workflow. Can someone stop marking on the board? Huh? Dhanasekaran.
Well, he has been given access.
Yeah, he has not been given access, right? So,
Gopi,
Given access. He's not been given access.
then
okay.
how he is writing?
How he is right?
PS, can I just correct it, PS?
Okay. So let me proceed further. So in this framework on carbon capture and storage, we have so many steps. We have to screen the geological sites, and after that, the site selection has to be done. We have to see whether wells drilling is through fault or seismic seals, which would be faster. And but sometimes we have to see whether we are not damaging the fault. So many studies, geological studies, has to be done for the site selection. And based on the selected site and geological data, they will do the modeling and assess the risks what are there in storing those areas, whether any leakages would be possible, any nearby reservoirs would get disturbed. So those things they will study. After that, a detailed characterization decision gate will come. The final decision gates will come. So we have to detail out what are the methods and which location we are going, how much carbon dioxide we will be pumping. So much details it will be required at this stage to produce this report on detailed characterization, including the static modeling results of the reservoir, geological formations, all these things will be included. After the detailed characterization, design and development for this carbon capture. So basically, the sizes of the wells, casings, all those things, as well as the reach and the direction of injection, all these things are important, as well as the velocity, pressure, and the temperature at that exits. So those things are considered as design parameters, and a proper design is done for carbon capture storage under reservoirs. And this risk assessment is done finally before the FID. FID is the financial investment decision for any project. So before that, they will do proper design as well as risk assessment. So this completes the framework for a carbon capture site selection, basically. And this is the workflow involved in it. It's a big area of research going on. Each topic in hydrogen research is not fully matured. It is all going on in that areas until we will get a success one day. A lot of challenges are there. I will highlight them. And any interested one can further pursue on research also. So a lot of opportunities also exist. So next, this is the well after injection. They will seal the wellhead with valves, and sometime it is connected to the DCS systems to monitor them, the wells also. Whether sudden pressure increases there inside reservoir, is there a sudden temperature drop, or any other influences. So reservoir management software would be there. That reservoir management software would require a lot of field instruments installed in these wells, and they will monitor from DCS systems with the reservoir management system software over a period. And because it has to be kept under control. Some other wells, these are mainly done with oil and gas companies, where they use it for enhanced oil recovery, the first type. Whereas the second type, which is abandoned type, plugged and abandoned, is normally done when it is not a enhanced recovery area, or it is not a gas or oil field. For any other locations, normally the countries decide just inject them into the reservoir, store them, and then plug them with heavy concrete plugs, so that the pressure doesn't exceed the concrete bonding stresses in the wells. So above which you can still grow greeneries and things. So this is an abandoned well. Whereas the first one is active well, where enhanced recovery and oil depletion things are there. And This is the monitoring I was telling you, just now, measurement and monitoring of the wells which are already drilled, and enhanced oil recoveries are made by pressurizing carbon dioxide inside. Basically, the monitoring program of the injected carbon dioxide into reservoir, the carbon capture, they have all these data, reservoir properties, site and locations. Then monitoring phases will come where pre-injection, if what before injection, during injection, post-injection, all the measurement data are collected, as well as monitoring items. They monitor for the plume, where the CO2, they will check at the environment above the well, whether any CO2 gas is present, is it leaked from the reservoir. So many monitoring checklists are there for the after the carbon capture is done. So these are some of the checklists which you can see in the last column. Some of them: top seal integrity, overburden monitoring, reservoir monitoring, seismicity, all these things. So carbon capture itself is a very big field going on presently. Now let us come to the, we have seen how we capture the carbon dioxide produced. We will now see how to store hydrogen, storage solutions for hydrogen. So the produced hydrogen gas is mostly in gaseous form, and to make it into liquid, we have to cool it down to minus 253 degrees centigrade. So which is very absolutely very low temperature, and achieving such temperature requires a lot of challenges, and it's the cryogenic temperature. So the cryogenic state achieving and as well as maintaining itself, big researches are going on in many institutions. Basically, in space research, cryogenic engines are being used. India started developing cryogenic engine for hydrogen in the year 2003. They are successful in testing the hydrogen cryogenic engine. In 1994, they decided to develop cryogenic engine indigenously in India. And in 2003, they successfully tested the cryogenic engine. And in 2014 only, they successfully launched a rocket with that indigenously produced hydrogen cryogenic engine. So it took roughly 20 years in a big space agency where only government control is only there. So you can see the 2 decades gone, even with the full government control and support, to reach the maturity in the research and to get success in a project. So we have to be patient. Definitely hydrogen area will mature successfully, but a lot of agencies all over the world are under research, doing research, but it is still not in a matured state, we can say. You will see also later. So hydrogen storage is a big challenge because there are 2 forms of hydrogen. One is gaseous form, which is very light in density, and it occupies more volume. As we see, 1 kilogram of hydrogen gas requires 11 cubic meter of volume space. So it is very huge. For a truck to drive a truck, you may need 10 to 12 kilograms of hydrogen for 300 to 400 miles, big trucks. So what you need is, you cannot store them in 10 into 11 or 110 cubic meter, because the truck volume itself is lesser than. So how to store them under atmospheric conditions? It is not possible. You have to either cool down so that you reach some lower temperature and compress it. So the methods of storage are always associated with compressing the hydrogen gas as well as lowering the temperature. Both can be done parallelly to achieve a optimum efficiency for storage. And with the storage tanks only, the mobility is possible in terms of trucks, vehicular transports, marine transports, or train, whatever it is. So for mainly for transportation industry, storage is a big concern and challenge which has to be addressed. And a lot of research has gone through. Many companies have already succeeded also. And many trucks with hydrogen powered trucks are already on sale, commercially on sale also. And many cars are also on sale. They are running everywhere. Except in India, in China, if you take, there are 250 hydrogen filling stations. Whereas in India, we are talking about one or two only. So vast expansive growth is there in China. And China is number one producer of hydrogen until now, not even United States. Now, coming to the storage method, it can be stored either as gas or liquid, as I said. If you store it as gas, again under high pressure tank, you can store a good volume of hydrogen. The high pressure tanks are normally built in the range of 350 to 700 bar, which is roughly 5,000 to 10,000 psi tank. So with this pressure, hydrogen can be stored under partially compressed state. Then hydrogen cannot be fully compressed to make it a liquid form. You need definitely low temperature. And as you know, the boiling point of hydrogen is minus 252.8 degrees centigrade. To achieve them itself is a challenge. Hydrogen can be stored on the surfaces. This is a new research going on through a process of adsorption. Adsorption is a process by which you can fill in the voids between the solids by means of thrusting the gas into them. And some kind of chemical attraction or affinity is also required to keep the hydrogen gas entrapped in such solid voids. So they are trying some metallic oxides and metallic hydroxides as solids for adsorption. And this method of storage of hydrogen is in very big form. Research is going on in United States. And some of them have got success in some oxides. So these are the methods I was telling you how already I talked about this physical method of storing hydrogen by means of compressed gas in tanks, or both lowering the temperature and compressing, you can achieve some efficiency in storage. And liquid hydrogen, definitely it is at a very low temperature and in the cryogenic state. And so these are the physical methods. And the last one, what I was talking about, adsorption of solids, the voids in solids, that is the material-based storage of hydrogen, wherein adsorbents are there, some liquid organic method, interstitial hydride chemicals, and complex hydride method, chemical hydrogen. All these methods of research going on how to store hydrogen efficiently in them. But I believe the methods of storage would be slow in solids due to the voids are not aligned in one line. They have to reach in random path to enter the voids. And not only that slows down the rate of storage, but it also may limit the amount also, because the voids may not be so high. But in compressed state, it can be possible, or in lower temperature, it can be possible, or with some chemical reactions, some innovation may be possible. So research is still on in this field. Now we have the hydrogen tank. Hydrogen tank, we have type 1, type 2, type 3, and type 4 different types classified by Department of Energy in US. So these types are all basically for compressed storage only. And here most of them are double walled. That means inner wall is there, then outer wall is there. In space research stations, they have very big spherical tanks, not this type of cylindrical. It would be spherical in a very big area. In space rocket launching locations in NASA or in India, everywhere. So those tanks of hydrogen storage are spherical with a double wall again. There is an inner wall, there is outer walls, both are spheres, and in between these two spheres, they will create vacuum, absolute vacuum, so that the low temperature is not transmitted through vacuum. That is in case of launch stations, such kind of storage mechanism is adopted. Here in type 1, we have large storage capacity. We can up to 200 bar. It is classified with this can go up to 200 to 1000 bar. This range and large capacity, and it is made of metal. And because it is metal, it is heavier. The tanks are heavier, and mobility is not possible. So this type 1 cannot be used in vehicles. It cannot be used in vehicular transports. We can see later also. Type 2 is with some polymer layer inside, metal with the polymer layer wrapping, and it can go up to 300 bar. Type 3 usually up to 700 bar, and it is lightweight. It also have a metal liner only, and with the CRPF HTP polymer liners are there. Type 4 is the most sophisticated. It has a plastic liner with composite fiber reinforced plastic polymer with this CRPF layer also, and it can go up to pressure. It can sustain pressure up to 700 bar. This type is more mobile. Mobility is possible in type 3 and type 4. Type 3 is medium range because it's still heavier due to metal liner, whereas type 4 is very light. Type 4 is easily possible to carry in trucks. Most of the trucks have type 4 type only in US. But the problem with type 4 is it is very costly, because the CRPF liners required fiber reinforced HTP and extrusion of such polymers. So those things are involved in it. Type 4 is very. You can see some storage tanks here. This with internal high density polymer liner is there. Outside is the carbon composite. This is basically the first one. What you are seeing is basically a type 4, and the second one is mainly type 2 or type 3. So it has double wall, you can see here. The storage. This is the storage hydrogen storage tank. They are developing for aeroplane. Airbus in France developing this for a new Airbus that would run on hydrogen. What they are saying, it would run on hybrid fuel. It will have conventional fuel as well as hydrogen separately, so that in case of any emergency, they don't want to take risk. So this hydrogen powered Airbus aircraft is under development. It is under research and development in Airbus. And you can see the hydrogen storage solution here is a big tank with outer wall and inner wall. And a suspension mount is there. And pipes are there for heating and for refueling and extraction. So actually the piping and assembly is involved also poses a challenge because for hydrogen transport and conveyance, they are under good research. So we have the fuel cells. Now we come to the how to use the produced hydrogen, the application method. So in this application method, we can have different types of mechanisms by which we can utilize the produced hydrogen. One is the very common method, which is called a fuel cell. It is used in the electricity generation. The input is just hydrogen and oxygen, both the gases only in the fuel cells, and they produce heat, and water is the byproduct there. The fuel cells are different types. They have SODC, MCDC, we will see later. These are mainly used in vehicles and buildings. Fuel cell research has come out with so many fuel cells, either alkaline type or proton conducting type. So we will see one by one later. Then internal combustion engines also being developed for hydrogen, especially the company by name Cummins in US. They have already patented a few internal combustion engines, and they have also made a truck using the internal combustion engine using hydrogen. It is simply, the mechanism is simply like in our normal combustion engines, except the fuel would be hydrogen, and other things are parameters are different, and seals are to be very tight here, because as I told you, hydrogen is the lightest element in earth, no? So having atomic number 1 and molecular weight 1. For this smallest element, size also very small, it will easily leak through the seals of the engines or turbines. So a good amount of research is undergoing on how to control the leakage of such a smaller element like hydrogen. Whereas if you take natural gas, which is methane, the molecular weight is 19. So 19 times it is bigger. And the seals are really designed for containing methane. Whereas for hydrogen, still research is ongoing. And many companies are successful, like Cummins, so many GE, they are all very successful in getting the turbines as well as combustion engines. Another area of application is gas turbine, hydrogen gas turbine, purely hydrogen gas turbine, and or a mix with gas turbine. In the mixed gas turbine, they mix LNG, that is liquid natural gas or natural gas with hydrogen, and then they run the turbines in certain proportion. Say 30% hydrogen, 70% natural gas, or 40% hydrogen, 60% natural gas. So some amount of carbon dioxide emission they are controlling in mixed gas turbines also. So it is very much useful to use mixed gas turbines for big applications, since the research is still ongoing for hydrogen, purely hydrogen gas turbines. And for space rocket launch applications, they fully use hydrogen gas systems at cryogenic state mostly, because space stations can afford cryogenic creation of cryogenic states, because they are not bothered about cost. So now we will see the fuel cell which we are talking about in application part. The produced hydrogen is there, stored. It is stored in tanks as we see earlier. and we bring it through piping and use it in the fuel cell. So once you put hydrogen and oxygen into the fuel cell, you can see here hydrogen inlet is there, oxygen inlet, and the fuel cell converts this into electricity. So electrical energy is the output here, whereas input is mainly hydrogen and air or oxygen here. And water is the byproduct because water is produced by hydrogen, mixing hydrogen and oxygen. So as I said earlier, in space station, I told you here, they are using hydrogen, no? So in space station, they use fuel cells also. In one of the US spacecraft by name Apollo Commander module, in Apollo Commander module, they have used this a sort of alkaline fuel cell. They specially designed. So in that cell, by injecting hydrogen and oxygen gas, they carry in the spacecraft into the fuel cell. The fuel cell gives them electric energy, which they use, the electric energy, they use it for the spacecraft operations. And not only the fuel cell gives the electrical energy, the fuel cell gives out water also, no? So that water, they are using it to for the drinking purposes of the astronaut crews. So it serves dual purpose in the spacecraft for them. They take both electrical energy output as well as water produced from the fuel cell. They use it for drinking purposes of astronaut crew or any other washing purposes within the spacecraft. So the application of mind is required wherever we see such kind of innovations, increase the efficiency, how to put them of more use. So innovations are required in all the fields, especially in the new technology areas. Here, one thing you can observe, this works under the principle of, again, with anode and cathode. So at the cathode, you let in oxygen, and at the anode, you let in hydrogen. And this fuel cell, which is an electrolytic cell with separated by a polymer membrane or something like that, it is a lot of different types of cell membranes are there. An alkaline membrane is there. So different fuel cells for different intended purposes are available now. So combining one fuel cell, you can see so many fuel cells, you can stack it there. One fuel cell normally produces 25 watts to 100 watts power. So if you combine 10 fuel cells, you get 1 kilowatt hour, 1 kilowatt roughly, 1000 watts. So normally this one big stack, what you see, would be capable of providing about 50 to 100 kilowatts each stack. So if you combine all of them, you get 1 megawatt in one row easily. And this is the fuel cell, which is called a solid oxide fuel cell, one type, which is a type. It is made of a dense ceramic layer inside the electrolyte, and it conducts oxygen ions. The electrolyte must conduct oxygen ion. That is the characteristic of electrolyte in an electrolysis process. They operate even at a very high temperature, 1800 degrees centigrade, due to this, because hydrogen is highly combustible, enormous heat is released. So that is why you need a dense ceramic layer. Ceramic is good insulator of heat. And next fuel cell, it has non-platinum catalyst. The catalyst is required inside the solid oxide fuel cell to accelerate the release of energy. It is mainly platinum catalyst. Platinum ones are very costly. That is why research has produced platinum ones now. These cells, what you see, they are produced by Bloom Energy in United States. And what you see here is the location of Google office in USA, where they have put all these solid oxide fuel cells in the Bay Area in California. And here, Google office is electrified with these hydrogen powered fuel cells, which are renewable energy, a clean fuel. So Google is gone for a clean fuel in their offices. This is the headquarters for them. And here they installed these kind of solid fuel cells right before 2008 roughly. They started installing. So 15 years ago, they have already started installing. If you take in India, there are thousands of IT companies. None of them have any such fuel cell electrifying their operations. So we are well behind. We have to improve. The efficiency of these fuel cells are 50 to 60%. With the combined heat and power, that is, when you reuse certain flume, then the process is called a combined heat and power. So with that, you can go up to 70 to 80% efficiency you can achieve in solid oxide cells. It is mainly used in residential, commercial complexes, and mainly stationary generator. It cannot be a mobile type for this case. Then comes molten carbonate. Here the electrolyte is ceramic matrix with molten carbonate salt mixture. So you can change the electrolyte, you can change the anode type, cathode type, operating temperature. So the parameters, they try to change and do sensitivities in the research. So they come out with different fuel cells. So this one carbonate is a molten form, and this molten carbonate fuel cells have efficiency 50 to 60% again. They are also applied in stationary applications, either in commercial or in the residential buildings, storage areas, warehouses also. And another type is proton exchange membrane fuel cell. Here there is a polymer membrane which is there, and typically it's made of platinum inside. The catalysts are platinum, and these fuel cells operate at cooler temperature only, so 80 to 200 degree Fahrenheit. And this, because the platinum is a very costly metal catalyst, and operates better efficiency at low temperature. And having an efficiency, this type of cells 40 to 60%, and they handle very rapid power output changes. So the power generation is very rapid here, and it is applied in vehicles like cars, forklifts, quick startup acceleration wherever required, and also in telecommunication data centers in big means. Nowadays, the research is ongoing to change the platinum to non-platinum. So with the non-platinum, so many patented proton exchange membrane cells are also available. So those things are used in these cars and data centers, etc. So now coming to the internal combustion engine, in USA, Cummins have developed this internal combustion engine called B6.7 ICE, and this operates seamlessly on hydrogen fuel, and this is suitable for even trucks with 10 to 26 tons of gross weight, and it has impressive rating, very high output rating, roughly 290 horsepower, and it can give up to 1200 Newton meter peak power, peak torque. And it employs advanced 700 bar pressure, high capacity hydrogen storage, which I told you type 4 with HTP polymer membranes with carbon fibers. It is fully made of polymer and carbon fibers. And so the combination of this hydrogen storage solution is a bit costly. So it has in this, they developed a truck also later with this engine. So that truck incorporates the fiber reinforced concrete composite tanks, 2 numbers into it, each of them having a capacity 20 kilogram hydrogen. So the total storage capacity of hydrogen is 40 kg. With 40 kg, the range, mileage range at which the truck can go is around 500 kilometers. You can see the truck in the next page. So they have developed this truck with two twin, you can see the fiber reinforced concrete hydrogen storage tank, one on this side and one on the other side, cylindrical ones. So twin tanks, each containing 20 kilogram hydrogen, and the engine is in the front portion of the hydrogen engine, which is the internal combustion engine they developed. Cummins have developed indigenously, and it is a successful one. Now coming to the gas turbines, hydrogen gas turbines, Turbotech in Belgium, a company by name Turbotech, they have successfully developed hydrogen gas turbines, purely hydrogen gas turbines without any mix with any natural gas. And this gas turbine is called their innovative model HYTG 550. So this gas turbine has is used for marine applications in ships where you require huge power. So turbines are normally used where huge power is required, like industrial applications. Mostly in steel producing mills, you need huge power. And if you use fossil fuels like petrol, diesel, coal to produce huge power, huge amount of carbon dioxide you will be releasing. So in order to control them, the steel mills as well as the marine ships, so many container ships and ship transport is going on in the world. If all of them emit so much of carbon dioxide, so many industries, they emit this, then for huge power, huge amount of billions and tons of carbon dioxide already occupies the atmosphere. So in order to reduce them, we have to use clean fuel like hydrogen. Purely hydrogen gas turbines are a big boom to the industry. Many companies have developed, not only Turbotech, many companies have developed successfully hydrogen gas turbines like Mitsubishi, GE, some of them like few other Japanese companies also. They have developed hydrogen gas turbines. But pathetic state in India, nothing has been done yet on hydrogen gas turbine. Still on research and development, even though we have so much of IT resources, so much of supply chain resources, still the innovation, development, the creativity to succeed and the perseverance to follow up is not there still. We need to improve on that. So this hydrogen engine generates what they have designed here. It generates 550 kilowatt, roughly 737 HP of electric power, and it significantly boosts vehicles' propulsion and energy capabilities with this power. turbine design is not simple. Many of you mechanical engineers would know turbine is a blade with rotor. You can see in the next page. Yeah, this is the rotor blade inside the turbines. The shape of the blade, for determining the shape of the blade, you have to run computer analysis using CFD. CFD is nothing but computational fluid dynamics. The fluid, how it interacts with these walls of the rotor blade and pushes them and compresses them in an optimal way to get highest efficiency. So we have to see that objective, that this utilize the fluid to push it to the highest efficiency. So that kind of rotor design, we have to get it done using the computer programs like computational fluid dynamics, using that pathways. A lot of softwares are available for CFD, and it's running CFD itself takes weeks and weeks of time. Now with supercomputer, it will take even few days. So it is not simple to design the turbines, and there is no Indian manufacturer designing such novel turbines or rotor blades. And we are mainly lacking in this area. This is mainly required, turbines are required for aircraft industry, industrial power generation, marine propulsion, and so many areas. So turbo engines are not as easy as internal combustion engines, and they are highly complicated, and a lot of challenges are there in turbo engines or turbines. Some of them are here. As I already told you, hydrogen is the smallest element having smaller molecular weight, and this can easily leak through the turbine seal if the seals are not properly designed to contain them. So that is one area where research is required also. And CFD is another area for rotor design and improvement in turbine qualities. And another area is the combustion inside turbine, the flame position and things like that. That area also research is highly required. Hydrogen has much higher adiabatic flame temperature than conventional fluids, and it is not like natural gas or kerosene. It has higher flame temperature, and this has a problem because of the higher combustion temperature with pure hydrogen, it brings problems like flame flashback, with the flame which flashes back or returns back to the fuel nozzle, and the fuel nozzle gets damaged, catastrophically damaged sometimes. So this has to be overcome. All these companies, what I told you earlier, the Turbotech or GE or Mitsubishi, they have already overcome this problem. They only know how they have overcome, because it's all patented copyright. They will not disclose to the public. So many of the challenges they have come back, they already have overcome, and they have been successfully commercially marketing the hydrogen turbines or mixed gas hydrogen turbine with natural gas and hydrogen. Now we have completed application part of hydrogen. Let us come to the area where the storage challenges are there. How do we store for so much of mileage range? So 1 kg of hydrogen is required for driving 100-kilometer driving, and so I already told you large volume around 11 cubic meter is required for 1 kg of storage of hydrogen. So all these things requires this different storage solutions. So different storage volumes are being tested. Now, there are many, let us go to the Indian government policy first. on hydrogen. One second, I will come to that. Yeah. So this is the Indian government now, the policies they made for hydrogen and their initiatives they have taken positively. So India has already went to the climate conference in Paris. They have signed to cooperate with the Global Climatic Pact to reduce the global warming temperature below 2 degrees and to achieve net zero. They wanted to become energy independent by 2047, and India's aim is to achieve net zero carbon footprint net zero. Here net zero means it is the carbon footprint which is net zero required by 2070. So this is the objective set by Indian government. They want the carbon footprint to be zero by 2070. The carbon footprint is nothing but the amount of carbon dioxide and greenhouse gases either an individual or an organization produce and inject it or emit it into the atmosphere. So that carbon footprint has to be reduced to net zero sooner for reducing global warming. So India is committed to that. So to achieve this target, they have the National Green Hydrogen Mission, and this mission was approved by the Indian Union Cabinet on 4th January 2022, after that is post-COVID. And the objectives of this National Green Hydrogen Mission, NGH, that is, there are two main objectives for them. One is to making India a leading producer and supplier of green hydrogen in the world. Then number two, creation of export opportunities for green hydrogen and its derivatives. Then, so these two has to be achieved through their initiatives. So to tackle the objectives, the Indian government also proposed so many measures and initiatives, which we will see shortly. Their main objective out of this in forming National Green Hydrogen Mission is to first initially they committed to produce 5 million tons of green hydrogen annually in the country by 2023. So by 2023 end, they aim to produce 5 million tons of green hydrogen, not blue hydrogen, it is green hydrogen. And this is a big challenge. Here, the blueprint in this India's National Green Hydrogen Mission, they have different objectives and policies. They have defined mainly 5 million tons of green hydrogen by 2030. Sorry, not 2023. It is by 2030. And 6 lakh new jobs will be generated according to them. 50 million tons of carbon abatement cumulatively possible. And so that would be captured and handled. And 60 to 100 gigawatts of electrolyzer installations possible. 125 gigawatt renewable energy, including solar, windmills, have to be installed for the green hydrogen production. Green hydrogen is produced only through renewable energy. So, parallelly, you have to increase the investment in solar and wind energy also, or in biomass also. And it requires in totality all these things to achieve all these objectives. They estimate around 8 lakh crore of Indian rupee investments required. Not only now, over a period of 3 to 4 decades. So now enabling the policy framework, the Indian government initiatives have announced. They said interstate transmission charges for renewable energy is waived. So they will waive the interstate transmission charges when you state to state, when you transfer the renewable energy, the tax is waived, sorry, and facilitating renewable energy banking and battery supply systems. Then time-bound grant of open access and connectivity. Whenever you have access, you can give it to any factory and open. You can access any of the required consumer. You can find and then sell it to them. Your power, produced power. So these are the initiatives. Then infrastructure development that would go hand in hand with the policy frameworks would be to develop the supply chain in India. They are mainly pitching in for Atma Nirbhar, which is Indian companies' participation, highly expected, and the development of supply chain within India. They are required mainly for putting up hydrogen pipelines, hydrogen tankers, intermediate storage tanks, then distribution networks, as well as the electrolyzer development. So many of them, as well as for the renewable energy production like solar and wind energies. So the initial estimate is 19,000 crore according to them, and they already started pilot projects for manufacturing green hydrogen. So this is the supply chain. When we come to electrolyzer, why electrolyzer has to be addressed? As I told you earlier, the objective of Indian government mission here is to produce 5 million tons of green hydrogen annually by 2030, not 2023, by 2030. So to produce 5 million tons of green hydrogen, you need electrolyzer only, through electrolyzer, and you need solar and windmill powers. So in order to achieve this objective of national hydrogen mission of India, that is 5 million tons, you need to focus, all the supply chains in India need to focus on producing electrolyzer or utilizing electrolyzer, or the supply chain which is involved in internal components of electrolyzer, all these things mainly. Number one. Number two, they also need to focus on solar, windmill, biomass, and other energy sources creation to produce hydrogen. So the supply chain related to electrolyzer gets important because of this objective of Indian policy. There are so many global players producing hydrogen electrolyzers. They are listed here, like Bloom Energy, China Shipping, Cummins, Enapt Green Hydrogen Systems, Haldor, Siemens Energy. So many are there. ThyssenKrupp. And in India also, it is not that much of technology based, but there are so many Indian manufacturers now presently available. Bryce Chemical is one of the noted one in Pune. They manufacture alkaline electrolyzer. GAIL India, they promised to produce electrolyzers by end of 2023. CPCL, Chennai Petrochemicals Limited in Manali, in Chennai, they have, it's under IOCL, and they have policy to produce, design, manufacture, commission, and produce and sell the electrolyzers. That is their plan by 2025. And there is another company by name OMEM in Bangalore. They are already producing PEM, up to 0.5 gigawatts. Is a very big capacity, and they are producing it in Bangalore. And titanium tantalum, TI anode fabricators. So these are some of the local electrolyzers manufacturers in the supply chain. And these are some of the blue hydrogen leaders who are really producing the blue hydrogen, not the green. Blue hydrogen, as I said, it is produced from fossil fuels, natural gas or coal, and the carbon capture is done properly. Carbon capture as well as storage or utilization is done. So these blue hydrogen leaders are mainly here. These include ExxonMobil, Shell, Saudi Aramco also, Air Products. And these are some of the green hydrogen leaders. Here we have GHI leading, and Global Tyson Group in electrolyzer manufacturers, BP in producing green hydrogen. So these are the top leaders of green hydrogen. One of the EPC providers, they are very important for putting up any hydrogen electrolyzer or plant. Especially for blue hydrogen, you need many people, many EPC providers. As you see here, this blue hydrogen leaders who produce blue hydrogen, but the EPC providers are here. Linde is one of the best company providing EPC solutions for putting up either green or blue hydrogen. So similarly, Wood, Tyson Group, so many are there. And we come to the end of the presentation in hydrogen, except that little bit on economics. The hydrogen production in India is currently high because the industry is not matured yet. It is an ongoing process by which they will reduce the cost of hydrogen when produced in a mass scale. So currently the price would be higher. Roughly the per kilogram of hydrogen, green hydrogen cost 400 to 500 rupees. And the cost of blue hydrogen costs 250 to 300 rupees per kg. This is the current scenario. But Reliance Industries, Ambani's have agreed to relook at it, and they have promised to reduce the price of hydrogen, green hydrogen, by one US dollar per kilogram. $1 is roughly 80 to 83 rupees per kilogram. So this is their promise of Reliance Industry in another 15 years. So by 2035, you will get at this price. So many industrial measures are ongoing. Many researches are ongoing. Nothing is matured in hydrogen area. So this entire presentation so far now has come to an end. I have given you an introduction only to the hydrogen area, and we have touched on many important aspects of hydrogen production, storage, carbon capture, and other aspects, why hydrogen is required and all these things. So with this, I have come to an end. Before we end our presentation, I would like to share the video of our company by name Afghans, which is the part of Shapurji Pallanji Group in India, which is one of the third largest construction company in India, and one of the best infrastructure providers, who undertakes a lot of challenges in Indian projects. So we also have an oil and gas business unit, which was formed in 2008 and 15 years back. And we have done more than 3-4 process platforms of very big, complex in nature. with very small teams and highly efficient teams we have. And many oil and gas projects like oil terminals, refineries, also so many projects we have successfully concluded. So this video presents our Afghan's legacy. So we can just view this, how we do in infrastructure in Afghans. Hopefully you can see the video.
இன்னும் ஓடுதுங்க.
Thank you. So we have now come to the end of the session for the question and answers. So we can, if you have any queries, I will try to answer.
Thank you,
Good
Ramanathan.
afternoon, this is
Excellent
Stalin.
session.
At the outset, congratulations for a very nice compilation of detailed information. I just have 2 points. Number one, I get a feeling that this entire thing depends upon how effectively we can store and transport hydrogen. And another thing is carbon capture. These two seem to be the critical in the entire concept. But these two seem to be still on an infant stage. Is my understanding correct?
Right now, many of the US companies have broken this record. They have found, they made ice breaking already. They have been successful.
Especially to
But
liquefy.
still it is costly. Their solutions are
Exactly.
costly.
I'm coming to that.
But
Because
ice breaking has been done.
see, my concern is on one hand, we are trying to substitute the fossil fuel energy. On the other hand, storage of hydrogen, especially the liquefaction, going to something like minus 250 or minus, that also
Is a challenge.
consumes a lot of energy.
Lot of energy, yes.
And storage of, transportation of hydrogen, if it is by a liquid at such a high pressure, and to my knowledge, it also requires some special metallurgy and all that. It's not a normal metal because
material of construction is very highly important.
A very exotic material of construction.
But normally they don't transport at the cryogenic states also. They liquefy with some compression and lower temperature. And in storage tanks also, it is not to the full extent that they lower the temperature.
Okay, so anyway, as you rightly said, let the research move on further and the cost of production come down. Right now, it may not be
maturity in research only can bring mass scale production and lowering of costs.
The second
cost
point
is reduced, then risks are reduced.
The second point is very fundamental or preliminary in nature. See, after all, we are producing hydrogen from non-conventional energy like solar, whatever it is. So why to convert to hydrogen and then why to generate energy? Why not solar power or any other source of power go into the direction?
Let me attempt to answer this. Of course, we are getting power from solar directly or from windmill directly. Why don't we use it instead of producing hydrogen? Yes, that is the question. Correct question.
Correct.
The reason is we split water molecules and produce hydrogen and store it in tanks. Whenever we require it, we use it. It can be stored safely for longer periods. And it can be used whenever it is required. And if it is instant use, batteries, storing the energy, electrical energy in battery is too much costly. Not only costly, but the extent of GHG emission for battery making itself is too high. So how much is the battery size? It depends again. Some batteries even the volume of the batteries are occupying nearly half the size of a room, normal room. So basically,
my point is slightly different. Why to even store the energy? Because we are trying to substitute the energy from fossil fuels with non-conventional energy. As long as the energy is produced, let it keep on getting pumped into the grid. And let's say that at one point of time, you get a lot of power from non-conventional energy. So to that extent, the utilization of fossil fuel is going to come down. And let's say at night time, you don't have the solar energy. At that time, fossil fuel is going to get used up. But instead, if you are converting to hydrogen or store in batteries and then once again try to get it back, once the chain becomes longer, always the efficiency comes down.
Yeah, true. So the reason here is you don't get wind speed at every place. You get wind speed at one place, and another place you need the power, requirement of power at a different location, whereas the wind speed is higher at different other location.
But
So
I think the
to
system
generate
is
some other place and you have to bring it too long here. Instead, they generate offshore, say some windmill, and there itself they convert it into hydrogen and pump it into pipeline, so or store it there, and then transport it. That's the solution they are doing it.
But I think even now the system is, if I want to have non-conventional energy, I go to a place like Nanganeri or some place and install windmills there, pump the power into the grid, and then draw it here after paying the wheeling charges or whatever it is.
Yeah,
Is it?
directly you can use it. Yeah, but the issue is if the demand is there, if the consumer right now he is available, then you can instantly use it. But the best method is to store it in an energy form like hydrogen and then use it in the fuel cells whenever you need, wherever you need and whenever you need. So that is the motto here. And moreover, like solar, you can harness solar energy only during sunny days. And in winter, 3-4 months or 5 months, you don't get anything. In areas in Russia or Sakhalin or Siberian climate, only 3 months are having sunny days. The rest 8 months, 9 months, they don't have solar power many times. So those are the areas where they cannot survive without this kind of energy.
No, that is exactly my point also. In such areas,
Yeah.
you go for a huge investment for generating hydrogen, but you will not be able to generate hydrogen for 9 months in a year. So huge capex, but utilization only for 1/3 of the year.
Correct. And they sell it to other countries. Russia is not keeping it with them. They are selling LNG, hydrogen to other China and other countries.
Anyway, let's
So
see.
for them, it is a commercial output. Yes, sir. Mr. Murali.
Let's see how the development goes on further.
Yeah.
Thank
Sure,
you.
sir. Thank you, sir. Yeah.
Sir, I have recently read out, I mean, it's a layman point of view, layman learning, that somebody in Coimbatore have invented using hydrogen for the car, which the technology have been sold and copyrighted to an Japanese company. How does it stand between these inventions and this particular case which has come out in the newspaper?
I'm not aware of it in general, but there are so many industrial centers of innovation in India. Forget about German or Japan. If you want anything on rotating machinery or engines or pumps, you go to the hub is Coimbatore only. And if you want anything to be fabricated like pressure vessel or storage tanks or any fabrication area, you go to Trichurapalli where BHEL's contractors are plenty. So there are a lot of centers of innovation of industrialization automation within India. We don't internally indigenously we don't realize. It could be true. I don't know. I haven't seen this news to comment on it. But I believe a lot of people are there, capable people are there within our industrial zones. You don't need to really go to either US or Japan or any other place to get these kind of solutions.
Yeah.
It could be true. Yeah.
Shall I ask a question? My name is
Yes, sir.
Muralidharan. Can I ask a question, please?
Yeah, please go on, Mr. Murali.
Please go on.
Okay. You see, the recently couple of months back, the government of India, under the green hydrogen policy, came out with an expression of interest for Green Valley project. Because they are following suit with 18 countries. They have had their own Green Valley project. So they have asked for certain companies to go for helping them go for a DPR. Do you know anything about it? Have you participated in that DPR, expression of UI on this thing? Because the technology has to mature, because as you say, we have a very limited scope for, getting the electrolyzers and all that in India, because a lot of international companies are there. In fact, I've been talking to certain European countries for extending this further to a fuel kind of thing. Like they are converting that using the carbon dioxide capture, hydrogen through renewable sources, and they are mixing it and converting that into methanol and to give it to a pipeline kind of thing for the ships and all that. That is a kind of technology that is what they are building in Europe. Can we have because one is cost, because renewable energy, it is almost matured now, but though you say that the efficiency is gone up because of the bifacial interventions and all that are there, from 19% this thing to 26%, 28% and all that are there. Even the hybrid models are also available. They are clubbing both wind energy and solar to come out with the hybrid model. As regards the storage is concerned, you have pump storage models are available, so that you can have, especially countries like Sweden and all that, they have the pump storage model to store it, and they have a cost effective models created using pump storage models. Hydrogen is yet to mature, as you say. 2047 is the time frame that is what is given. 2030 is the time when these people have brought out with 5 million MMT of this thing is produced. Are we still in a position to go for a cost-effective model? Do you think the technology will mature within this period of between now and 2030? Are we in sync with the international COP21 summit? These are all the points that I would like you to emphasize and highlight.
So let me come one by one for your queries.
Right.
The first query you raised is on the whatever I know, I will try to share. Otherwise, there are many experts in this forum who will also share on the process side.
Right.
So your first query is on the establishment of the Green Valley, where Indian government participation was there, and you are asking about the further follow-up on that issues. What I understand is there is going to be a hydrogen conference soon in Delhi, in September first week somewhere.
Okay.
So there they will reveal this Green Valley discussion has been slated in one of the session also. I'm also participating there. There is another thing which I need to inform here on the Green Valley project is the Reliance Industries in Mumbai, that Ambani owner, he has proposed to construct Dhirubhai Ambani Green Valley in Jamnagar.
Okay.
So this is not a simple thing. He has already invested $10 billion and he has promised to invest till $75 billion US for developing this Dhirubhai Ambani Green Valley project in Jamnagar, which is next to their Reliance refinery, and to produce green hydrogen. And he only promised, I will bring down the cost of hydrogen by $1 per kg of hydrogen. So this project with them, they are trying to produce electrolyzers. I understand they have tie-up with a few Swedish companies also, and they are trying to produce green hydrogen. They are trying to produce electrolyzers. They are trying to produce fuel cells and many other supply chain areas in that valley. So that is the mega project undertaken by Reliance. Already 10 billion has been pumped. They have promised 75 billion over 15 years of time. And they promised to reduce the hydrogen rate by $1. This is
now,
the
what will be, what will be the
news.
conversion rate of Indian rupees then, because unless and until, today it is pegged at 82 rupees a dollar.
He announced only last year. Could be in the range of 78 to 82 mainly.
Okay.
So this is their present scenario. About the Green Valley, and regarding your next query, that is on the further development and maturity. Yes, definitely maturity has to happen place. The idea is there and it is a good idea of clean energy. Challenges are always there. Without challenges, we cannot, failures are really stepping stones. Without challenges, we cannot come out. Like, India started developing cryogenic engine in 1994. Now we are successful. Each and every rocket of Indian rocket carries is thrusted by Indian
I know.
indigenously developed cryogenic engine.
Okay.
So if we bog down without that, we cannot proceed and progress further. So challenges have to be overcome by proper innovation, and that too, if it is an indigenous innovation, it is welcome. So there are so many people within India, but they are mainly sleeping because either they don't have the financial access or technological access. Some introductions may kickstart them. So this kind of conferences would give them kick innovative thinking, right?
Especially for the electrolyzer manufacturing, do you think, do you foresee any international company would collaborate with India under the startup ecosystem?
Already so many companies have
Especially the
tie up,
companies what you have
like
displayed, like CPRL and all that, they are in the space and they have the adequate wherewithal to do it. I'm talking about the startup ecosystem where
yeah,
the collaborations can come in from international,
yeah, it
collaborators.
depends on the scale of the startup. If the startups are small, of course you cannot go to big US giants and have a collaboration. So it depends on the scale of the startup. Smaller startups normally start with the internal components required for electrolyzers. You
Okay.
cannot suddenly manufacture a big electrolyzer. So depending on the startup size, they would decide their contribution to the.
Do you think the cost of hydrogen today, as you said, for 1 kilogram, it's costing about 400 rupees? Will it come down by any means?
Definitely, it has to come down when it is produced in mass scale. As
Okay.
Reliance also has promised, they will bring down to 80-85 rupees per kg in
But
another 1 or 2 decades.
it's a long drawn haul because
It's a
we have
long
to
drawn
be
haul.
it's a long drawn process. But the thing is, what is the kind of incentive that is there if anybody wants to get into this? Because green, as you talk about, even for a smaller size, installations, you require about 3 megawatt of this thing with, a lot of space required for building this kind of technology. The cost of 3 megawatt itself is a costly exercise in order to create some sort of this thing and to produce hydrogen, as you said, it would be better if I throw that to a grid, and without wheeling charges. Today wheeling charges are there for state to state this thing utilization, and I can save it. What is the incentive that will come
That will
about?
drive. You mean?
Yeah, drive this.
Fine. I got your point. Yeah. You are asking why? What is the need for me to go and invest in hydrogen when I can do it with the conventional fossil fuel type systems to generate the similar energy content, right?
Yes.
So the reason is we have limited fossil fuels in the world.
No, I'm not talking about fossil fuel. Even for the renewable energy,
renewable energy.
Because we have the technology is matured. In fact, we have bifacial systems and all that where.
I think the similar question
and
was
we have a clubbed hybrid model where vertical wind farms and all that can be clubbed so that to enhance that volume of production even in off season, because even 3% this thing radiation, we will be able to generate electricity. That's the kind of model that got matured, especially in renewable energy space. And if you pump it into the central grid and wheeling charges are not there, you stand to gain rather than losing.
Correct. True. The mainly
What is the motivation that is required? Because the
similar
kind of
question was raised already by Mr. Stalin also here. Okay, the reason is it's not perennial that solar power would be available. It depends on sunny days. Similarly, wind power, it is not constant place to place as well as time to time and season to season. So these powers are driven by seasonally driven power, and they are not constant and consistent. Whereas hydrogen, if you generate and keep it, it is consistent power guarantee is there with you, storage, and it is cleaner. And in case of transport mobility solutions, you cannot go with solar or wind. You cannot instantly generate wind power and drive your car. You cannot instantly generate electricity using solar or wind and then drive your truck that are your ships. For example, big ships, they cannot install solar cells or windmills on top of ship and then try to generate and then carry on with the seas or continental oceans. They cannot cross. The reason is very simple. These natural energy sources are not consistent. They are only seasonal dependent, location dependent. So many unreliability factors are behind them, associated with them. Whereas you generate oxygen and hydrogen and keep it in a storage tank, you are guaranteed you have a power guarantee. Whereas with other things you don't have. And similarly, now innovation is also in a big way, as you already asked me, innovation area, that in ships, as you pointed out, the marine ships, they are crossing oceans, continental oceans, the thousands of kilometers they have to cross. Across them, there is no land space, full of seawater. And the only way, better way for them is to use seawater to generate the electricity or hydrogen.
Do you think
rather than fresh water?
No, as they move on, will they be able to generate it and utilize it?
Yes, now research has gone up to the level that the ships can take in seawater and then they can separate hydrogen from the seawater, store it and move it on.
Okay.
They can move it on, they can fully power the turbo engines of the marine ships using hydrogen alone. And with the seawater alone.
You know, with the
seawater
carbon capture tower and all that can be built in there.
In 2019 March, a team of researchers from Stanford University under the name Dai, a Chinese guy, 3-4 researchers have been highly successful in converting marine, the seawater hydrogen splitting from seawater.
Okay.
So they have been highly successful. The challenges with the seawater is it contains chlorine and it corrodes the anode quickly. Eats away the anode.
Brine formation is there.
It eats away the anode within 10 to 12 hours.
Yeah.
Whereas if you use their method of coating on the anode, it prevents them for thousands of hours, and they have been highly successful in that.
Okay, what about the safety of the aquatic animals there? You know, they throw out the spent.
Ocean is very vast. That the animals are less than 0.56% of the volume of the ocean. So you have plenty of water to withdraw, and that too they put filter actually below, so the animals cannot enter it actually.
That's what, you know, the kind of discharge and all that, you know, they have to have a proper discharge methods. Okay.
Sure.
Raman, can we just move on? There are others. I think this can be taken up offline as well.
Yeah, sure.
Gopi, can I ask
Yeah,
you?
please. Yeah, please.
Yes, sir.
Okay. I'm Vishwanath, 82 batch chemical.
Yeah, welcome, sir.
I've been a composites man all my life.
Okay.
I have the privilege of Mr. Sita Raman, our illustrious alumni, Mr. Sita Raman, chairman of Super Auto Forge. So he wanted to go for the hydrogen storage technology. In fact, he wanted me to come on board. The project was a 26 million euro Italian technology for 500 bar storage. 500 bar storage of hydrogen, vehicle composite tanks. I declined because potentially you are carrying a bomb in the car, and you know, the regulations are still not yet. Any accident happens, it can be a thing. I just want to share, if normally 250, 300 bar in steel cylinders type 1, it is 1% hydrogen. Suppose you are carrying 100 kilogram of steel cylinder, 1% is the weight hydrogen in it, 1 kilogram. Exactly. If you use composites, you can improve it to 2%. If you, 2 or 3%. So my thing is, 2% by weight hydrogen. And if you go for, I mean,
As you
doesn't
said,
make sense.
it is really a bomb only, like a risk. But
And the cost today,
it cannot be pursued as a bomb because you need three elements to make explosion or fire. One is heat, then oxygen, and this hydrogen fuel. Please see, when you make anything, these three never combines together, so you don't get a bomb at all.
no, 500 bar, just the pressure itself is so high. Any
Correct.
incident of impact itself can be what. The other thing is, I believe that even 20 years back, NASA was saying that instead of an electric grid, you will have a hydrogen grid. You will have a hydrogen grid where you want energy, you want to use battery, you can just draw from a hydrogen grid.
Correct.
Probably that is what Mukesh Ambani is talking about in his Green Valley.
Yeah.
The real challenge, I believe,
With a
in
small
hydrogen,
pipeline, it will cater to many domestic households. Hydrogen pipe may come in future. And,
I am also
may draw energy from there.
Yeah. One more thing I think the material of construction will be composite because hydrogen embrittlement is a very big problem.
That is the
If you
biggest
use metal.
problem. In turbines also, it is the biggest problem. So
Yeah, it's a
the
big
material
problem.
of construction has to be titanium or ceramic, and which sustain high temperature, as well as this embrittlement, like titanium we can do, ceramic coated titanium. So those things are, innovations are still going on this area.
So I believe pipelines, cross-country pipelines, just like CNG will be in composite material in hydrogen. One thing I wanted to just share with you, they say the fastest, the low-hanging fruit is compressed natural gas with about 18% hydrogen, because already the grid is there. You can enhance
mix the gas.
Yeah, you can enhance the calorific value by adding about 18% hydrogen in existing compressed natural gas grid.
Like
that may
what
be
they
the
do,
fastest.
ethanol, they blend ethanol with the petrol now, no, in diesel.
Yeah.
So similar type, you can blend hydrogen with compressed natural gas and send it to the filling stations.
Yeah, because already the infrastructure is there. Already the infrastructure is there. That may be the low hanging fruit for thing.
Yeah.
And so this is the
engines need not be changed.
Totally changed. So I feel
all are similar.
Yeah. Initially it will be CNG doped with hydrogen to enhance the calorific value.
Correct.
And the problem in seawater electrolysis is chlorine. See, when you are electrolyzing seawater in the anode chlorine along with oxygen, chlorine also will produce. IIT Madras has developed a technology now.
Yes, IIT Madras also developed a scheme. Not only that, there is an institute by name CSIR SECRI in Karaikudi.
Karaikudi, yes.
A Central Electrochemical Institute in Karaikudi. And that institute has done a lot of innovation in hydrogen area, electrolyzer area, especially on corrosion. They are number one in the country. So they have done similar anode protection for marine water also, as well as they have developed a few electrolyzers for hydrogen generation as well as fuel cells also, and they have patented it them also for 5 kilowatt and up to 100 kilowatt, 100 watts, not kilowatt, up to 100 watts. They have done the fuel cells and electrolyzers. They have patented also. Similarly, IIT Madras also has done a research on seawater, especially on the chemical engineering department. I know them; they have done it. And the only successful one which they announced in a commercial scale is that Stanford University research, which I was mentioning. They have used nickel-based hydroxide and nickel sulfide coated in nickel, pure nickel anode to prevent them from corrosion, marine corrosion. That
sir,
is attacked
you
by
didn't mention about ammonia, sir, because isn't it easy to sequester hydrogen with nitrate? Make ammonia can be easily compressed, easily transported.
Correct.
Have you your thoughts on that, sir?
That also some research going on with ONGC. ONGC started policy on making green ammonia and using them for extracting hydrogen later. They have joined hands with the Greenco of Abu Dhabi. Greenco Abu Dhabi and ONGC have this project ongoing already.
Thank you, sir.
The
Very,
research
very
has to mature,
interesting
as you
presentation.
say. Yeah.
Thank you, sir.
Thank you, sir.
Participants, you may please unmute and ask your question, please.
Yeah, hi, this is Thiru here. Tirupati.
Tirupati, yeah.
Elecon in the gray hydrogen, produce gas direct use. Why do we need gray hydrogen or otherwise the blue hydrogen?
It is only the color coding classification.
Yes,
Only
because-
two hydrogen in that coding are important. One is green hydrogen, another is blue hydrogen. All other types of hydrogens are not recognized by any of the countries or by global warming bodies. So the gray hydrogen is just a color coding, but yes, of course, as you say, instead you can directly use methane. But the amount of carbon dioxide by methane usage would be much higher than going through this channel. Some amount you can reduce, that's all.
The carbon capture you can reduce by using carbon capture, and then you can use the hydrogen.
Yeah, then if you do carbon capture, it is not called gray hydrogen, it is blue hydrogen.
Okay.
Hydrogen doesn't have color, but it is the artificial naming we
The
gave
way you
that
produce,
process
you
basically.
color coding it.
Correct, yeah. So you belong to 1987 batch, na?
Right.
Yeah, Tirupati, yeah.
Right. I remember now.
Great. Is there any
Gopi,
commercial?
Yeah,
projects
please go on. Please go on.
Sorry.
Ramnath sir, I am Meenakshi Nathan from Sivagasi, 1984 chemical.
Oh,
I think
okay, sir. Okay.
little bit senior.
Okay,
Where is your native? What is your native?
I am from one place called the Kulibira near Karakudi. Yeah.
Oh, near Karakudi. Okay. Right now you are in Mumbai?
I am in Mumbai. Yeah. I was
Very good.
so
Okay.
far in Singapore, Malaysia, now moved to Mumbai.
Oh, very good. Okay. You quoted that in September there was some meeting in central government in Delhi.
Yes.
It is for only for a closed group or for new developers?
It is a global conference on hydrogen.
Acha, we can also attend.
More than 100 countries are participating. Yeah, it's a big one. Yeah.
Okay.
And
You need to register, Meenakshi.
Exhibition stalls are there for hydrogen. You can easily go and get the brochures and develop your supply chain there easily. It's a very big conference. Yeah.
What is it? What is the full name of conference name? Gopi sir, you know it?
Yeah, I'll give you. I'll share.
I will share it. The flyer sheets to Gopi.
Yeah.
And he can circulate to you.
Okay. If it is possible, we will meet there, sir. I can get your number from there. Okay. Thank you. Thank you. Thank you, Gopi sir. Thank you.
Is there any commercial viability projects have been done on a smaller scale, like not like Adani and Ambani?
Yeah. Under the National Green Hydrogen Mission, they have more than 380 crores allocated for pilot projects. Already pilot projects have started, and some of them are due in 2023, and some of them already successful. In NTPC, it is already successful. Some projects in IOCL already completed. They are successful. They have installed many the hydrogen refueling stations in the cold areas like Leh Ladakh by IOCL. So those pilot projects are also complete. The production of hydrogen also in that area, and then it was pumped to the metering stations. So similarly, NTPC did a lot of work, and they have promised to generate power from green hydrogen to the tune of they have promised some tune of about 100 kilowatt by 2030 something, but their pilot project has started already. Similarly, each big public sector in India on oil and gas, like IOCL, BPCL, then whatever you call, ATPC, even L&T has started making green hydrogen. About 45 kilogram of hydrogen they are already generating in their Gujarat plant. So that is ongoing, and all these pilot projects have been successfully generating hydrogen. Similarly, the research institutes like CSIR, all these things, they have already developed, patented, and successfully tested all their hydrogen generating electrolyzers. Especially Sikri in Karaikuti is number one in this. So it's all ongoing.
But in viability projects, அதாவது வந்து ஒரு 3 megawatt, 5 megawatt அந்த மாதிரி இதுன்னு இல்ல.
They have, see, if you take many models in Sikri, they have from 5 megawatt to 100 megawatt they have. You can visit them also. And they have already patented successfully those things, the electrolyzers. Similarly, it is just the research institute, but lot of supply chain you have to look at if you want to explore commercially. I have projected just now in the slides lot of commercial production companies for electrolytes. About 3.8 to 4.5 kilowatt one electrolyzer is being produced in a company in Pune, something called Prime or Price, something I just projected. So that so many pilot models of that size have been already floated commercially, is all available.
Okay.
Sir, my name is Bappi Raju. I am friend of Mr. Gopi. Actually, I worked in CPCL. Recently, I retired from CPCL.
Yeah, Gopi told me.
Yeah. Actually, your lecture has been quite exhaustive and, in fact, covering almost all the features, right from the inception to a kind of little taking transportation up to transportation levels and all.
Yeah.
See, as such, as you rightly pointed out, refineries are the main kind of clients of hydrogen, I can say like that. They do kind of utilization of hydrogen in their refinery process is much higher. That's why the Ministry of Petroleum and Natural Gas has been also insisting first refineries to take a kind of steps to see that, see that their hydrogen, whatever has been produced so far, it's a kind of a blue hydrogen coming to green, gray to green and all now. But I have a fundamental doubt always just comes to my mind. So I always kind of northern part of India, they do take a kind of fast forward steps in this kind of technology than southern India, where intelligentsia is quite high. Is that a kind of capital that is required is quite high? That is number one. Number two is that generally, like see, if you want to set up a refinery, or if you want to set up a kind of fertilizer, or if you want to set up a steel plant, it calls all these are all quite capital intensive. Is that hydrogen generation, green hydrogen generation, it will also take, I think, same level of expenditure. So southern India doesn't have that capability. Why always we look for Ambani, Adani, or some kind of some northern based companies only? This is what I think a little bothering. It must be bothering us, being a kind of most of the participants must be from southern part of India. You have any opinion on this, sir?
True. Probably the business climate is the best suited probably in and around wherever the financial capital is there. They are all assembled. Probably the business climate is well suited, but it doesn't mean any part of the country is deprived of any of the rights. So everyone has equal right to put anywhere, and it is only our own perception that I believe we have to have our own thinking to put up in any part of the country. So it can be done. Basically the main problem for our underdevelopment could be, most of the things, policies, even maybe in different language barriers are there. Probably they may not reach to the southern end or tip, and those concessions offered by government, how to climb all those things in different language barriers, may not reach probably. So that is where the acceleration is required for all the fellow Indians to utilize the initiatives announced by the government. And I believe all have equal right, and it is only our perception. We have to change, and we have to work to go towards utilizing all the benefits extended by the government equally. Yeah.
So I would like to just add on.
Yes, sir.
Always the people who know why employ the people who know how. So the South Indian people know the how. We are, well-trained engineers and intellects. So we know the how. So we end up working for the people who know why. People like Adani and Ambani. So we lack the risk-taking aptitude. Even parents will not allow children to enter business or enterprise. So we are very happy working for somebody. That is the reason why.
Take the risk. Many of them I have seen. Many of us, we don't take the risk to enter any business unless you are into it. If you feel the risk, then only you will think of a solution to come out of it. If we don't enter into a risk at all, we don't know about the further progress and growth also.
Gopi, can I ask a question?
Yeah, please, Ashok, please.
Mr. Ramanathan, thanks for an excellent view of hydrogen economy and the importance of the same to India. But as a resource-constrained country, and the challenges with hydrogen as a transportation fuel, which is where some of the things we talked about. I think Vishwanathan also touched on this. Do you think we should be equally looking at ammonia as a more alternate choice because it's more safer and maybe more easy to be used as an alternate? For sure, hydrogen has its role. Hydrogen has its role in certain areas where we can't deny. But when you have a limited amount of money, why not focus more, which is more easy to achieve, and there is already a mature technology for ammonia compared to hydrogen, where we are still looking for it.
Yeah. As a fertilizer, definitely the amount of ammonia we require, we are really buying from other countries. So that we can reduce really. So instead of the other way is to, ammonia highly portable, and it's also that cleanness, it can be extracted. But in general, every stage, the research has to be there in a mature state to adopt any of these solutions possible. And especially the role of educational institutions and CSIR like research institutions are important here, so that we get a maturity to come to this stage.
I am Dharshekaran, 81 Chemical.
Yeah.
Sorry, my apologies to you and the ABN team because it was not intentional. I was listening by a handset and the.
Oh, no issue.
No, I just put it inside my shorts and I was preparing tea.
Okay, no issue.
Good, you alerted me.
Yeah, no issue.
My sincere apologies. Anyway, it was very excellent presentation, and a non-chemical guy covering so much in depth.
We used to hear many courses on finance for non-finance people. So it reminds me here, a process topic for from a non-process guy probably. So.
No, excellent one to know the latest developments. Thank you so much.
Thank you.
Good afternoon, sir.
Good afternoon. Yeah.
Sir, I am Sarana Kumar. I am just graduate from chemical engineering, sir.
Okay.
Sir, I am interested to working in a oil and gas or in EPC like company, sir. But nowadays there is no opening for freshers like that. They are every company is asking for 3 to 5 years experience like that. Means where can I get that experience? How can I approach someone to get a job like that, sir? Now I am working as in a startup
What people
EPC.
do? Yeah, it's a good question. Really, everybody is supposed with in their initial careers, they would have struggles and challenges. Every one of us in this forum have gone through this. It's not only you. So it is not only addressing you. Everybody is having the same issue. Of course, there are means to overcome this difficulty. Definitely, the corporate companies will not employ without any experience. That is clear. So what you need to do, definitely you need to gain some experience in that line of field of expertise. Like, you join a small company where you can easily get. There are some consultants, small consultants or smaller EPC companies where you can get, and adding that experience so much years, then you can build up your own career. Interest also important. You must have the interest to pursue that goal. You must have the interest to pursue into the oil and gas career. So in any topic, you should have the interest first. Then you will definitely achieve your aim and objective. There are so many public sector also. You can go as apprentice, and or even private sector also. You can go as apprenticeship or training, and then add the trainee experience also into your resume. So
SK
there
can
are
also
ways and means. Yes, sir. Please share.
SK can also SK. You can also try to work in companies which make valves, pumps, accessories in oil industry.
Right.
Become an expert in There will be small companies in Ambattur who make equipments for oil field.
Yes.
And that experience, they'll be ready to take you, because small companies making valves, measuring instruments. You can join them, and I mean, you will meet your customers who are indirectly connected to oil field. Take a jump, take 2 jumps, and you will be in oil. Not a
Correct,
problem.
sir. Correct, sir. Very correct.
Small heat exchanger makers, small people who go and install equipments in oil field. So you will have access to oil field. You will meet some people, and then your experience you can add to your resume.
Yeah, exactly. So as a senior, as you said, it's good for all the fellow juniors who are hearing here. Don't be bogged about all these things. Be positive and work with the small companies and add those experiences. Little drops of water makes the mighty ocean. So whatever you make, small amount of experience you gain, you just list it down. What technical expertise you gain from that work, what you did, all those things put in your job description in the resume, and then file it up later. So it all helps really.
Sir, I am already working in a startup EPC, sir. Hello, sir, but the work is just doing some editing works on files, like removing logo and adding some logos like that. Is that really give me any experiences on oil and gas with or EPC like that, sir? I don't think like that. So I need to
agree with you. There are certain logo companies where you cannot gain any experience at all. They may put you in some inspection area also, and you will be standing there, and you won't gain any design experience or anything else. But it is your own will with which you try to work yourself, maybe during evening hours or Saturdays, Sundays. There are plenty of courses available now, online courses available now. You take any academy, online academy, undergo a course on many courses available in oil and gas, even in any mechanical equipment course, pipeline design course, piping course, HVAC design course. So many things are available online course. You can build up your expertise If you stand in the company, it gains your experience. If you join the online courses, you gain real expertise. So it is the will of your mind by which you have to think, not in the negative way. Carry on. Any other questions from anybody?
Ramanathan sir, this is again Nathan. Since you are being from Karakudi, CSIR இப்ப நம்ம நீங்க சொன்ன மாதிரி பேட்டர்ன் பண்ணிருக்காங்களா அந்த ஹைட்ரோலைசர் வந்து 3 கிலோவாட்ல இருந்து 100 கிலோவாட் வரைக்கும்.
Many of my friends from Mumbai here also. Could you talk in English, sir? Yeah.
Oh, sorry. Okay, you have any connection with the Karakudi Sikri about that patented technology to be given to the private-public partnership? Do you have any connection?
Directly, you can go to the institute and ask for I met few people.
Meenakshi, sorry.
Meenakshi, the director can help you put up to the hydrogen team.
I can connect you to one of my classmates who's there, who's the deputy director.
Oh, very good. Okay.
Our batch, 87 batch, one person is there. I can connect you there. Don't worry.
Okay, boss. Thank you. Thank you, sir. Thank you very much.
They are doing very good work on that hydrogen. Yeah, they are. And there is another CSIR institute in Pune, I think. They are also doing. They have done a breakthrough with many electrolyzer designs. Yeah.
Okay.
Parvez, you can please ask your question, Parvez.
Yeah. Thank you, Mr. Gopi. Sir, thank you very much for the nice, interesting presentation, sir. I am from Andaman. We are dependent on diesel for power generation, where we have small DG sets, 2 megawatt, 5 megawatts. Do you think you have this technology which is viable in replacement of DG sets, sir?
Definitely, any amount of power can be generated from hydrogen, depending on it's the volume only. Like as I projected to you, solid oxide fuel cell, SOFCs, they cater for this kind of thing, stationary and at industrial locations. It can be utilized. So many Indian manufacturers are also started to manufacturing it now. It would be cheaper. So SOFCs and other fuel cells are also available, which can cater to the requirement of a few megawatts of power.
So what would be the per unit power generation cost? Like presently our power generation costs something like 20 to 25 rupees.
Yeah. Actually, for example, 1 kilogram of hydrogen cost, I told you, is if it is green hydrogen, 400 rupees roughly right now. In future, it will reduce to 80 to 100 rupees in another 10 to 20 years. But right now it is 400 rupees for green hydrogen, 300 rupees roughly for blue hydrogen. So if you take 1 kg of hydrogen, it costs 300 and 400. Now, if you take 1 kg of hydrogen, the amount of power, electric power you can get out of it is 34 kilowatt hour. That is 34 units of power. If you take TNEB grid Tangentco, the power rating, how much it would be, Gobi? 10 rupees or 12 rupees? No?
10 rupees.
10 rupees per no? So 34 times 10, 340 rupees. The government will charge you, or Tangentco or any power supplier will charge you. Whereas the same amount of 1 kg hydrogen would cost you 400 rupees if you derive it from green hydrogen. If you derive it from blue hydrogen, it would cost you 300 rupees. So you are in the range right now, but it will go down. That's what I'm saying. In future, it will go down. Like as Ambani promised, he may sell it at $1 per kg, then it will be 80 rupees only then per kg.
But what is the cost of the equipment?
Equipment costs and all there, that would be initial investment. As mass scale production, it will also come down, right? As you have to invest for emergency diesel generator cost is there, no? Infrastructure cost. So likewise only.
So 1 megawatt generator and 1 megawatt of this hydrogen based, I think will be more of the same.
Sorry, 1 megawatt?
1 megawatt of diesel generator and 1 megawatt of hydrogen based generator.
But the issue is with the environment. If you are serious about protecting environment, you will go for which side you need to go, you know.
Yeah, thank you, sir.
Yeah, thanks.
Yeah, one last question. Sanjay, any addition from your side, Sanjay?
The one question I want to ask.
Yeah,
I just want a rejoinder before that. If you are producing by emergency diesel generator, I mean, generator, it will be 20 rupees per unit, not 10 rupees like Tirupati says. It will be actually 20 rupees. You know, in Pondicherry, many shops are using diesel generators because they have exceeded the limit of LT limit, and there is no way they can put HT. Our Ram Silks, Natarajan, 86 batch, is also having the same problem. 2 floors is exhausted the limit of LT, 150 kVA. So for the balance
Actually,
three floors is using
commercial rating is commercial rate is different. Residential rate is
DG set is operating at 20 rupees per unit. So in Andamans, you have to take 20 rupees per unit for I mean, if you are using DG. I just wanted to just add.
Correct.
Yeah, Sanjay, go on, Sanjay.
Yeah, sir, this is regarding safety in the truck which you had shown. So generally what happens is like solar and wind we don't use because we say that it has to be stored and the energy density is high because the energy per unit kg or energy per unit volume, both it helps in transportation. That's why we use in aircraft, shipping, road transport, etc. So it is basically energy density, but the energy density, whether it's per unit kg or per unit volume. But the flip side is like the safety aspect because of the high energy calorific value. So we have an engine in the truck which is in the front, and the chassis behind is where you have the tanks, composite, the type 4 hydrogen side, and then what happens is when the truck, when it meets any accident, compared with a petrol engine or a diesel or a diesel truck, the accident, if it happens, which is in the front side because the engine is getting hit, so that will be some leakages, and this is highly combustible, highly energetic, calorific value. What are the truck will have to do a design in the safety aspect itself, because
I got your point. Yes, of course, this same issue already exists in our daily transportation in CNG, no? CNG cylinders we carry in our many of the cars, right? So at the dicky, they put the CNG cylinder, and it is highly compressed natural gas. Same hazard already exists. Not only that, diesel and petrol also is hazardous. Of course, if such a hydrogen truck hitting any other accident, the tank may not get damaged because it may be designed also for the external pressure. They would verify using finite element method by applying some impact loads. So that is also there. And they could have certain minimum amount of impact, it would survive, no issue. Even in the worst case, as you said, if it gets ruptured, either engine side rupture or storage side ruptures, definitely there is a escape of hydrogen. But as I said, hydrogen is harmless unless it joins with 3 elements, fire or heat, then oxygen, then this hydrogen, no? So you see, you won't have any much heat, only impact will be there, but there will be slight increase, but it won't be enough to explode. So and hydrogen will quickly escape out into the atmosphere. Being lightest gas, it will go to the top layer of the atmosphere quickly. It will escape and go out. So it is the most safest as per, if you read most of the hydrogen standards, they say it is the most safest fuel in such kind of situations.
Okay,
sir, one other deterrent.
But we have to see these 3 elements doesn't combined together.
So
Oxygen.
So basically,
as well as,
hydrogen and CNG will be same. Hydrogen engine and CNG engines will be same. I mean, same.
Similar, no, yeah, some.
Same
Can, yeah.
Okay, sir.
There may be differences. Yeah.
Okay.
So one other thing, one other deterrent in this hydrogen cylinder, when we studied with Mr. Sitaraman, the cost, a 500-liter cylinder costs 10 lakh rupees.
Okay.
So the cost is a big deterrent, you know.
Yeah.
I mean,
yeah.
So yeah, to store the storage of hydrogen cost of the
right
cylinder.
Now, what you are talking about, sir, what you are talking about is the present scenario.
Yeah.
Once mass produced, once everybody started using hydrogen, definitely they will bring down the cost. It is not always going to remain at 10 lakhs. So it would become even 1 lakh or higher. So we don't know that. So we have to wait for the tankage side also, the research to mature basically. And as Mr. Sanjay said, we can protect the tank by means of some external steel skeleton properly designed also. And the engine also can be internally protected by steel skeletons that absorb the impact. So the vehicular testing, what they call the NCAP testing for vehicles, you know, that they can do differently for hydrogen engines and hydrogen vehicles. They can try regulate, guidelines may regulate differently for them.
This kind of challenges will always be there. Like, say, of late now we have been seeing the trains which have been going at 160 kilometers per hour, even 200, 300 kilometers per hour and all. Yeah. Like recently introduced Vande Bharat, you know. If you think that, suppose if it meets in a kind of, if it gets derailed, of course, it will be more disastrous. Of course, safety is inbuilt. Safety is yeah, safety gets inbuilt. I think technology will develop in those lines always. There won't be, as you rightly pointed out, yes, that threat is always there, but technology also gets geared up to take care of that aspect also.
The risk has to be addressed.
Definitely. Sir, actually, I request AABN, Gopi, you just say, as of today, so software is everywhere. I think the future is one in the hydrogen, as Sir also has rightly pointed out. Yeah. So more and more topics, if you get deliberated on hydrogen, it will be helpful for this forum. And maybe I think technology, then technology become a kind of, appears to be very simple and understandable rather than a kind of making it more complicated now. Maybe Gopi can look into that.
Yeah, noted, Gopi. I'll take it.
Yeah.
Okay, Ramanathan, I think we had
it was a really great session.
We had a very long session, in fact, a marathon session, I would say. Thank you very much, Ram, for taking your time out on a Sunday morning to be with us.
Thank you.
Pleasure meeting you. So we'll catch up soon, Ram, when I travel to Bombay next.
Sure. Yeah.
Okay, take care.
Thank you all. Thank you all for the participation. Thank you.
Thank you, Ram.